How about if we have a quotient? For example, let's say y is equal to x over 6. And this time, because it's a fraction form, if I just arbitrarily go -2, -1, 0, 1, and 2, it's not going to be a very pretty answer. So let me, knowing that it's a fraction form, choose some different inputs and outputs. Okay? For example, what if I say, what would the y be if I let the input be 12? And what would the y be if I make the input to be -6? And how about if I go the other way around? What if the y came out to be 3? What must my input be this time? And also, if my output was -4, what would the x be? That's a little boggler, isn't it? It's not as straightforward as last time where you just simply make an input and figure out what the output is. This time you have to think both ways. So let me explain. Let me demonstrate, actually. This one. We are given an input, remember? The x's are called an input. By the way, the input is also sometimes known as the domain. And if there's an input, there must be an output, right? So that's an output. And the output is known as the range. You may want to remember that when you're taking a California high school exit exam. I'm sure they will ask you this. Another simple way to remember that output is a range is, there's an old American folk song where it goes, home, home on the range, where the deers and the antelope. You remember that one? Yeah. And I always ask the kids, hey, where do cows go to output? Where do cows go to output? Out at the range. That cow better not output at your living room. Cows go to output out at the range. Output is known as the range. So, if domain, the input is 12, here's how you figure out what the y is. Y is x divided by 6. So x is 12 divided by 6. And what is 6 divided by 12 divided by 6? It is actually 2. So, the range is 2. If the domain is 12, the range is 2. So can you figure out what the range will be if the domain was -6? Why don't you try it? Okay, so if you did, you would have said y is equal to -6 over 6. And you go, oh, wait a minute. I remember this guy saying that when you multiply or divide a positive and a negative, it comes out to be negative. Yes, when you divide a positive and a negative, it's still a negative. And 6 divided by 6 is 1. So the range will be -1. Now you go, well, what about this one? Here, this time, let me write the function again. Y is equal to x over 6. Since this time, we are given the y, the range. So the y equals 3. So let's put that over here. 3 is equal to x over 6. We don't know what the x is. Now, you could do this one of the two ways. One way is to use your mental math. Use that brain of yours. I think that's a brain, or 2 cotton balls or something. Use that mental math and say, what divided by 6 is 3? What divided by 6 is 3? So you should be thinking backwards. Hey, that's like saying 3 times 6, which is 18. 18 divided by 6 is 3. So you go, yeah, 18. And it's correct. Now, if you wanted to show this algebraically, to solve for x, you take the denominator and multiply to both sides of the equation. When you do, the 6 numerator and the 6 denominator on the right side simplifies to become a 1. So 1x, or simply x. And on the left side, 6 times 3 is 18. There it is. So can you figure out this one on your own? Come on. Pause the video and try it. All right. So let me kind of tilt this a little bit so you can see what the other one was about. There it is. You see that right there? Yeah. All right. So what must the x be so that when you divide it by 6, it becomes a negative 4? So you say, well, let me write it the way you did over here. Instead of the y, I'm going to make the y into a negative 4. Negative 4 equals x over 6. Now, you could use your mental math. You're saying, what divided by 6 is 4? What number divided by 6 becomes negative 4? And you go, whoa, wait a minute. You went backwards last time. So can I just simply go 4 times 6 is 24? So 24 divided by 6 is 4? Well, yes. But how does it become a negative 4? Well, then this must be negative 24. And this is correct. And if you want to do that algebraically, like over here, you would take that 6 denominator and you would multiply 6 to both sides of the equation. So that 6 and the 6 on the right side, they simplify. So it just becomes 1x, or x, and 6 times negative 4. It's not minus 4. 6 times, 6 times minus 4 is negative 24. So there it is. Now, it only makes sense. Now, I take this simple quotient and give you the last example for this lesson by making it a little more spicy. So what if I said y is equal to x over 6 minus 2? Just like before, but whatever you get, minus the 2. And let me make a selective or selected number for inputs and outputs. Why don't I give you, like, let the x become negative 18 and negative 12 and 3. What? Actually, make it negative 3. And negative 2, I guess. How's that? Let's see if that works, huh? Let me pause here for a second.